Okay, time to get started for my last session of this TechEd. Not the last session, there's one more after this, but every time I get started at TechEd, I think, I wonder why this event ends on Thursday. Why doesn't it keep going until Friday? And then it gets to be Thursday, and I remember why. It's been a long week. I have forgotten how many sessions, but for this one, we want to talk about the assessment and deployment kit. And I'm not quite sure how I got volunteered to do this one, but someone said, well, wouldn't it be a good idea if we demoed every tool inside of the ADK? Yeah, it sounds like a good idea. How many of them are there? Well, there's about 17 of them. Okay, we need to do a session where we demo 17 different tools. So that's basically what we're going to do today. We're going to walk through each of the tools in the ADK and take a brief look at them. So first, we should talk a little bit about what is the ADK. It is the new version of the Windows Automated Installation Kit. It was released with Windows 8 and Server 2012. Now, things that used to be available as separate downloads are included within this kit. When you actually download it, you just download a little stub installer, and based on the components that you choose, it downloads the rest of the pieces on the fly. They put a lot of work into the assessment side of it, so that's where the A in the assessment kit comes from. Those assessments, as we talked earlier in the week, are really focused more on the OEMs, but that doesn't mean you couldn't use them as well. There are x86 and x64 components in the ADK. There aren't any ARM components in there because Windows on ARM, Windows RT devices are shipped pre-configured with an OS. You can't do deployments to them. You can't build your own images for those devices. That's the reason why there aren't any ARM tools. This can be installed on Windows 7 or above or Server 2008 R2 or above. Once it's installed, you get all of these tools. It is a free kit. There are no real restrictions on downloading it or using it. It just has lots of stuff. Basically, the building blocks that anyone would need to use to do OS deployment. It's going to be leveraged by things like WDS, by the Microsoft Deployment Toolkit, by Configuration Manager, probably by most third-party deployment tools as well, because anyone who wants to deploy Windows needs to use these tools to do it. As far as the installation goes, when you run it, it will ask you, do you just want to download the pieces? Do you want to install the pieces? Because it can download components on the fly, maybe you can't directly install this onto the computer that you want if it doesn't have internet access. So you could download ADK setup on a machine that does have internet access, use that to download all the pieces, then copy the resulting folder over to an isolated machine that doesn't have internet connection, and then run ADK setup again and tell it this time I want to install. It will recognize that it's already downloaded all the pieces, and it won't go out to the internet. It won't attempt to go out to the internet and download them again. When you run this on a client OS versus a server OS, you actually get a different list of components. Like in this case, we can see toward the bottom of the list, Windows Assessment Services Client. That would only show up on a client OS. If we were to install the ADK on a server, the list has one difference on it. It will show wherever it went. How do I get that other screen to show up? There is another screen there, but basically it will show Windows Assessment Services, the server component of that. So we'll assume that PowerPoint slides are not going to function today. But in the case of the ADK tools, this is the list. We've got the Application Compatibility Toolkit, which used to be a separate download. The deployment tools, the core command line tools, and just a variety of utility type tools. User State Migration Tool, Volume Activation Management Tool, Windows PE, Windows Performance Toolkit, and then Windows Assessment Services and the Assessment Toolkit. So we're going to try to go through all of those except for one. We'll skip over Windows Assessment Services just because in order for me to demo that, I would have to bring a whole stack of hardware, and my suitcase isn't big enough to bring all that stuff. Basically, Windows Assessment Services is designed to have a server running as a domain controller, running Windows deployment services with images loaded into it, and a whole lab of hardware where it can control every one of those pieces of equipment. from the standpoint of turning them on, deploying images to them, running a whole bunch of automated tests, and then passing all the results back and storing it in a central database for reporting. Useful for OEMs who are trying to do Windows logo certification, useful when you're wanting to do that kind of broad lab-based testing, not so useful in environments where you just want to run some quick tests. The Windows Assessment Toolkit could be used in that scenario, so we'll look at that one as long as we have time at the end. So the rest of the session then is, let's just walk through tool by tool by tool and look at them. So let me switch over to my computer here. So we'll walk through each of these. I've got the world's smallest PowerPoint slides off to the side to kind of give you a description of what each of these tools are, because if I had to keep flipping back and forth, we would never get anywhere. So in this case, let's look first at the Application Compatibility Manager. It's one of the pieces of the AppCompat toolkit that's designed to gather inventory, pull it into a database, and then let you look at that inventory. How many of you have used this AppCompat toolkit inventory tool? Only one? That's surprising. So it is a useful tool because it will allow you to gather hardware and software inventory, and then it will let you go out to the internet and grab assessments of those apps. So it'll tell you, what does Microsoft think the compatibility status of these apps are? What does the OEM or what does the ISV think the status is? And also what the community thinks the status is. Does this application work on Windows 8 or does it not work on Windows 8? So when you install the AppCompat toolkit, you would run through a wizard the first time to configure a few things. One is you would have to create a database. In this case, I created a database called ACT on my server here, and I enabled this machine to be the log processing service, and then created a share. So this share is where the inventory collector tool will drop its inventory. So basically you run the inventory collector on each computer, which is a very simple MSI, which you can run via group policy, config manager, or anything else that's able to run a command line. It gathers its inventory, writes it to that share. This service then wakes up periodically, sees that there's a log file there, opens it up, reads it, stores the data into the database. Very simple. So basically this one machine can collect files from thousands of machines and shove them into the database. It doesn't really matter what kind of machine you run this on. If it's on a fast machine, maybe it can keep up with the log files as they're being recorded, as they're being reported in by the machines. If the machine's not so fast, well, maybe it can't keep up real time, but that's okay. It'll keep chugging away until it gets rid of all the cab files, all the compressed inventory files that are stored in that folder. So easy to set up. In this case, the service runs as local system. I could run it as a user account if I want to. Basically, whatever account I use needs to have access to the database, as well as access to the log file share. So the next step then would be to create a data collection package. So if I click on Data Collection Packages and double click, it allows me to create two different types of packages. One is for inventory collection, so go out and collect an inventory of the machine and report it back. The other is a runtime analysis package. The runtime package actually sits on the machine and monitors what's going on for extended periods of time and allows you to look at AppCompat issues, Internet Explorer issues. So it's a little more specialized and isn't something that you would run on all the machines in your environment, but you may use this for sampling of applications to see what types of issues you may run into. The inventory collection one's fairly simple. You could run that one on every machine in your environment and that would be fine. In this case, let's call the package TechEd Collector. It has the share embedded into it, so it knows where to write the log files. And we can assign a label to this collector package. Basically, that label just means everything that's put into the database is tagged with that label. So you could generate 4 or 5 of these and be able to then filter the inventory data by the field that you put in there. Otherwise, it doesn't really matter what you put in. We'll say create, and then it will ask, well, where should this MSI be saved? So I'll say TechEd collector, which I've already got one there. I'll have to replace it. And now it says, well, the next steps are yours to take. First, you need to identify the computers you want to run this on. Make sure that you have write access to that file share that we created before, and then deploy the inventory package using your preferred method of deployment. Anything that can run MSI exec, name of the MSI file, /quiet, can execute this particular package. You can even do it using group policy. You can assign this MSI out to all of the machines. The installation is actually what runs the inventory. So the install doesn't really do anything. It doesn't leave anything behind on the machine. It just runs the custom action that collects the inventory and then exits. So we now have the collector, which if we go over to the folder that I saved that into, I can run it manually, which is this one. I can say install. It will sit there for a while. We can see a process running in the background, which is why it's showing an hourglass on the cursor. And that's all it takes. It's basically run an inventory. Now, the service will eventually wake up and process that log, so we should see it change from a month ago to 9 in the current date. We'll come back and see if that actually happens later on, but it will then store the inventory, which we can see on the Analyze tab. So I've done this on a few machines before, so we can see a bit of additional inventory from more than just this one computer. We can see the list of all the applications and all the computers that those applications were found on, as well as information on all the devices and drivers that are being used on those devices. So this can also tell you, for all the computers in your environment, what drivers are needed. Are the drivers for those in Windows? Are they available from an ISV as a separate download, or are they not available at all? Is there a question?
This is just a point in time.
Yeah, it's basically at the point in time that you ran that collector package on the machine. You could run it repeatedly just to keep getting more up-to-date information from each of the computers. It is smart enough to process multiple results from a single machine and keep the latest results. Okay, so in the case of applications, we can see the status on some of these, like, what's a good one? Microsoft Help Viewer. Let's just look at that as an example. We can see the name of the app, the version, the company. The vendor, in this case Microsoft, says that the app works on both 32-bit and 64-bit Windows. 4 people in the community voted to say that it's green with no issues. And we've found it in our environment on 2 different computers. We can see what those computers are. We can see the labels that we had put in the collector package. In this case, I had typed in inventory for one of the previous runs. And we can also set our own assessment on this. So if we say, well, we found an issue, we could come in and set an item here to say works with minor issues or has solutions. In this case, we know it works okay, so we can set it to green. For some of these, we'll see that there's no information available. Like in this case, Microsoft hasn't said that Dart is compatible with Windows 8. No one in the community has reported back an assessment on that either. So we can set our own assessment, say that that's green. And now when we send and receive, that information can actually be passed back to Microsoft to store that for other people to see. It's optional. You can review what data gets sent, what data gets received, but the idea is that you're contributing to that community evaluation to provide that data that other people can see about apps that may be present in their environment as well. So this will go out to the internet, to our application compatibility web services, passing details about the applications that were found, looking up any additional information available, downloading them and storing that into the database. And then for any new apps that haven't been discovered by anyone else, it will upload that data into the database. Once it's been seen on more than just one customer's computer, then it will start to show up for other people as well. It could be your own line of business app. We can see the footprint of it to know the manufacturer name, the version, some details like that. But if it's just coming from one customer, we may assume that it's an internal line of business app, something that we aren't going to show to the general public. But if it shows up on 10 different systems, then it's something that we can approve to be seen through some of the other websites that display the same information. So send and receive completed. We've uploaded our data. We've downloaded updated statistics about the inventory on these machines. It really just lets us try to focus our testing efforts. So the idea would be, now that we've got all this inventory in place, we may want to go through and set some labels on this, or set some priorities on this to indicate, well, where do we want to focus our testing? So we could assign our own categories. We can set the priority. Maybe we just want to do testing of apps that have been identified as business critical. But even ones that are business critical, if we know it's business critical and we see a large number of community reports that this app is compatible, we may say that's good enough for us. Let's move on to the next application in the list. So it's all about trying to focus your testing on apps where, if it's critical and no one else has tested it, or if other people have identified issues, you then have to look deeper at that application to see, should we test it some more? So that's the app compatibility manager, which allows you to collect this data. That's one piece of the app compat toolkit. The next piece is the compatibility administrator. So if we go to the compatibility administrator, this tool serves a different purpose. If we have an application where we found an issue with that application running on the new operating system, we can apply shims to that application to fix it. So it's all about trying to remediate problems that have been found with applications. Windows is kind of interesting. Over time, some of the behaviors inside of Windows have changed. But we don't want to break any applications. Wherever we possibly can, we want to preserve compatibility. So there is an existing in-box compatibility database where we say, for this application, here are the shims that should be applied. And it's quite lengthy, which has information on apps that you probably haven't seen in years, but usually when we add something into this database, it never gets deleted. So this data continues to grow, which is why we have information in here about the 102 Dalmatians Activity Center. Apparently there was an issue that was found in a version of Windows. We had to apply a compatibility fix that says emulate missing exe. So we have a variety of different fixes that we can apply to all these different applications to make sure that they work appropriately on every version of Windows. So that's what we do centrally to make sure applications are compatible. You can basically use this tool to do the same thing. So if I have an application that I discover has an issue, like in this case, we've got a stock viewer demo app that we traditionally use. If we know that it has an issue running on the new OS, we can fix that. In this case, the app has a hard-coded check in it that says, is this person an administrator? And if it's not, it comes up with an error message. Well, I am an administrator, but I have UAC enabled, so I'm not running with administrator rights. This app doesn't really need administrator rights. In fact, after I click OK, it continues to run and comes up fine. So how do I get rid of that error message? That's one of the shims that we can apply. So I can go into a database, say that I want to create a new application fix for stock viewer. select the executable, and just apply the fixes to that. So the challenge with this is really just figuring out which fixes need to be applied. And we have a few different sets of fixes that you could apply, like these compatibility modes. We could say, well, we don't know exactly what fix might be needed in this case, but we want this app to behave like it would have if it were running on Windows XP SP3. That will apply a common set of fixes for making it behave like XP SP3. So that could be something that you try. Otherwise, you could say, no, I don't want to use the compatibility modes. I want to use the individual fixes. And there are 398 of these fixes, so the question then becomes, well, which of these 398 do I want to use? In this case, I know it's something about administrator access, so I can scroll through the list and figure out, well, which one of these seems appropriate. There's one here called Force Admin Access. If I hover over it, it says this compatibility fix addresses issues that may be encountered when an application uses various API calls to verify if the current user is part of the administrators group. Seems reasonable. We can check that. Add that fix to an executable that matches the attributes of, that we select here. And then anytime that executable runs, that fix will be applied. Question? Yep. So if we did the test here, it would run that executable with those shims applied. So it would just let you cycle through some attempts faster. So if we did that, it should run the executable, and this time it launches without the dialog box. So, all right, that proves that it did fix the issue. So we can go ahead and click Next, click on Finish, and now we have a new compatibility fix rule that matches stockviewer.exe and applies that particular update. So we can then save that as a database. So we'll call this one TechEd, which gets saved into an SDB file. So I can save it as TechEd. And now I could actually deploy that to all the computers in my environment, which is fairly easy to do. There's an executable called sdbinst.exe. It's present in Windows. You just run it with that SDB file. And it installs that on the machine so that the system then has that new rule. In this case, we can even run that from within the console just by right-clicking and saying install. It runs SDBinst itself, comes back and says that the database was successfully installed. So now, again, if we run the stock viewer app, we shouldn't see that dialog pop up. So it really becomes a question of, well, what issues are in the application and how hard is it going to be to figure out what shims to apply to fix those issues? And we've got various partners and consultants who have gotten really good at this. So generally, if there's an app issue, they will figure out how to fix it by applying shims to it. This app has all kinds of other issues in it as well, so we could keep going and keep trying to fix it. Like it's got weird things like update kernel, tries to replace kernel32.exe. Obviously, it can't do that. You can shim that to make that succeed so the app doesn't generate any errors, even though it can't possibly really replace kernel32. You wouldn't want it to. So it's all about modifying kind of the behavior of the Windows APIs to make the application think what it's doing is actually achieving what it desired to get the application to run right. So that can be useful for fixing issues. If we wanted to remove that database, we could do that as well. Once it's listed, it shows up under installed databases. We can right-click and just say uninstall. Now it's no longer present. Now if we ran the application, it'll have the error message back again. So that's the compatibility administrator. It's useful, but it does require having some knowledge of what are all these shims, how do they work. So there are shims to do things like automatically click OK on message dialogues. So if you get an error message like the one that popped up, maybe we can't figure out how to get it to go away. Well, we can make Windows automatically click the button. When you see a dialog with this name, click the OK button. Maybe it's something that there's a hard-coded path in the executable looking for C:\WinNT. Well, now with Windows 7 and Windows 8, it's C:\Windows. So you can translate paths to make sure that the application looks in the right places for whatever it's trying to find. Lots of shims available to do pretty much anything you can imagine. So that's the second tool inside of the AppCompat toolkit. The third one is the Standard User Analyzer. Standard User Analyzer has a few pieces. It has sua.exe, which is a kind of a simple executable, and then there's a wizard version of it, suawizard.exe. We'll run sua.exe, which displays a dialog where we can select an executable and then execute it while it's watching what's going on. And based on what it sees, it can recommend shims that could be applied to that particular executable. So I can select stock viewer. I could say, nah, don't run it elevated because typically it won't be run elevated. And then I can launch it. So it will run stock viewer. Gets the message back again about not being an administrator. We can do some things like telling it to update the kernel. We could tell it to check for updates. Well, that generates an error as well. So the different things that we can do in this to try to break the application. But then when we exit, it will analyze the log file that was created as part of that and identify the different types of fixes that may be necessary, things it tried to do that weren't allowed. It did identify a couple of things with global objects and the APIs associated with that. And then it can generate mitigations for those. But if you notice, it really didn't identify the key issues that were causing those problems. It didn't identify the fact that, oh, it was checking for administrator access. It was trying to replace a file in the System32 folder. So it's not going to find all the problems, but it will find some. That said, there is another tool out there that's not part of the ADK, developed by one of the consultants that's actually here this week, Aaron Margosis. He has a tool called Lua Buglight that uses a different approach to the same problem. It watches the execution of a particular application, first trying to access a resource using low writes, like trying to replace kernel 32. And then it will elevate and try again. So it's basically watching the API calls. If the access fails running with low writes and then fails again running elevated, well, then that's just a normal part of the execution of the particular application. That's kind of a false positive. But if it fails with low writes and succeeds elevated, oh, that's something that maybe we can fix. We could fix by changing ACLs, by applying shims, by doing other things like that. So you may want to check out that tool for, especially when you're trying to troubleshoot standard user issues where your users are running with UAC on or are running without admin rights, which is definitely something we recommend. Lua Buglight, L-U-A, Buglight. I think it's available through Aaron's blog, which is on MSDN. Okay, so that is the AppCompat toolkit. Application Compatibility Manager we looked at initially. Compatibility Administrator is all about shims, which can be deployed and installed with SDB-inst. And then the Standard User Analyzer, where we can monitor, suggest shims, but maybe you want to check out Lua Buglight. Next in the list are the core deployment tools themselves. Things like BCD boot, which is a tool included inside of the ADK for creating BCD entries. If you're familiar with the way Windows 7 and Windows 8 start up, they've moved away from the old boot.ini file. They now use BCD file for containing boot information. A little more complicated than the old boot.ini, but it's something that you can manipulate using BCD edit, which is another command line tool that we'll look at in a minute. But to create a new BCD entry for a new OS from scratch using BCD edit usually takes about 10 to 15 different BCD edit commands to set each of the attributes for this new boot entry. BCD boot's designed to be much simpler. Point it at the operating system, and it will do the rest. So it will build a complete BCD entry for that operating system just by pointing it to the folder containing the OS. So in this case, I have a VHD file that I've mounted for another OS. So if I do a directory of V, I can see my additional OS. If I do BCD boot v:\Windows /D, because I don't want to accidentally mess up my system. /D basically says don't make this the default. I want my machine to still boot back into this OS that's currently running, not the new one that I'm pointing it at. That'll create a new entry, and of course it helps to do this from an elevated command prompt. So let me start an elevated command prompt. BCD boot v:\Windows /D. So now it has a new BCD entry. If we do BCD edit /enum, we can see an entry pointing to C. And if I could actually get to the scroll bar here, we could see the other one as well. So there's one here that's pointing to V, and then the second one pointing to C. So that's good, but it thinks that V is a physical disk. And V isn't actually a physical disk in this case. It's a VHD that I mounted on this system. So with Windows 7, Windows 8, Windows 8.1, we can boot from a VHD file. So we may want to create BCD entries for booting from a VHD file. BCD boot doesn't realize that this is a VHD file, so it created entries for a normal disk. But at least it did most of the work for us. Now we just need to go back and change two of the settings. We need to change the OS device and device entries. So first we kind of need to find the GUID of that new entry. Oh, I did make it the default. So /D makes it the default. So we can change via BCD edit /set default. And then we want to set OS device to VHD equals C:\, in brackets, which, yes, is a little weird, and then the path to the VHD file that I'm using. The brackets around C:, basically mean C is the literal, but I actually want it to be the volume serial number of whatever volume C currently points to. So that gets translated. So that sets OS device, and then we need to do the same thing for an entry called device. And now if we do BCD edit /enum, we can see a properly formatted BCD entry for boot from VHD. So now if I rebooted my system, it would boot into that VHD file instead of booting into the full operating system. I better not leave my system like that because it'll reboot and I'll wonder where'd my server go. So I better do BCD edit /delete default to delete that entry back out of there. So BCD boot is fairly useful for creating that skeleton entry. Maybe you need to change some things after it's added that, but it's not too hard to do than using BCD edit to do the manipulation of the existing entry. Yes? Yeah, the square brackets around the C colon, basically it's a way of indicating that this isn't a literal path. It's going to be replaced by the volume serial number of the volume containing C. So it's the currently assigned C. So like if I were to reboot into Windows PE at this point in time, it wouldn't be C anymore. It would be something else. And if you actually did a BCD edit /enum at that point, it's going to show what's the current volume assigned, putting it in brackets to say it's not a literal, it's going to change to whatever drive letter that volume is currently assigned. So it's just a kind of a quirky way of representing the volume serial number. Otherwise, you would see a long GUID in that place instead, and that GUID would be completely meaningless to you. So it's a lot easier to type it in this way. Okay, so BCD edit, BCD boot, you would typically only need to mess with these if you're going to manually set up a system for boot from VHD. So let's say you have an existing Windows 7 laptop and the Windows 8.1 preview comes out and you'd like to evaluate it. You can do that. You can go into DiskPart, you can create a new VHD file, you can attach it, which enables you to then format it and put a drive letter on it and apply the 8.1 image to the empty VHD file. So now you basically have a VHD containing 8.1. You can then run BCD boot to create a new BCD entry for it, BCD edit to fix up those two lines like we just looked, reboot, now you're in 8.1. When you're done testing 8.1 for the day, reboot, and now you can go back into your Windows 7 environment. So this VHD allows you to have a self-contained second operating system and do dual boot back and forth between them. Good way to evaluate the new OS. The other thing that you might want to do, though, is if we do BCD edit, oops, the first setting here is a timeout value. This timeout value is normally 0, which basically means don't display a boot menu, take the default option and boot immediately. In this case, I've changed it to 30, which gives me a 30-second countdown on the boot menu to choose between multiple boot entries using the keyboard. Or in the case of Windows 8, it could actually be a GUI as well, where you could select between multiple entries on a GUI boot menu. But 0 obviously isn't a long enough delay when you have multiple entries and want to choose between them. So in this case, I've changed my system to 30, but it's fairly easy to change that just using BCD edit /timeout. Maybe I only want it to be 20. Now when I look at it, the value is 20. So however long you want that timeout to be, you can change that. You can do as many OSs as you want. You just need, well, ideally you have each one in a different VHD file. So you could have 30 VHD files, 30 BCD entries, one OS applied to a disk. If you had multiple disks, you could have, or multiple volumes, you could have one OS on each volume, but that gets really messy and confusing. But I would recommend having one applied directly to the volume, whatever your primary OS is, and use VHDs for everything else. Not be able to boot without what? I'm not sure I quite follow the question. Right. Well, default in this case really means if the timeout expires, which one is it going to choose by default? So in this case, I deleted the default entry, so the next one becomes the default entry. So I just have taken it back to where the current is actually the default as well. They do some other weird things in this listing because these identifiers are actually GUIDs for all the entries. The default one will show up with default in the curly braces when the current one isn't the default. When the current one is the default, you won't see a default, you'll just see current. If there's one in the list that isn't the current or the default, then you'll see the GUID. So it's trying to be a little friendlier and use these kind of shortcut notifications for default and current to be able to differentiate. On UEFI systems, there are a few other gotchas with this where the BCD information isn't stored in a file. It's actually stored in the firmware. So all of this detail is in the firmware of the system. The reason why BCD exists the way it does in Windows 7 in a file is basically to align the behavior with what was going to be coming for UEFI. Now that UEFI is there, it uses the same setup for both UEFI systems and non-UEFI systems. So that's BCD boot, BCD edit. Next item in the list is bootsect. Hopefully this is one of those tools that you don't need to use very much anymore. So bootsect is designed to put a new boot sector on an existing disk. And the only real reason that you would need to do this is if you have a system currently running Windows XP and you want it to run Vista or above. Because the boot sector in Windows XP knows how to do one thing. It finds a file named ntldr and it executes it. The boot sector in Windows Vista and above knows how to do two things. It knows how to look for bootmgr.exe. If it finds it, it loads it. If it doesn't find it, it looks back for the old ntldr and loads that instead. So the new boot sector is able to boot either the new operating system, or if it can't find that, it'll load the old operating system, the old XP base. So the only time you need to run bootsect is when you're refreshing an existing disk from Windows XP to something Vista or later. The deployment tools like MDT and Config Manager automatically run this to apply an NT60 boot sector. So all you have to do is run bootsect, and then the different boot sector you want to apply, in this case NT60, I want Vista or above boot sector, and then I can say all to say apply that to all disks. And it'll go through and update the boot sector on all of those. We could also say instead of all, just a specific drive letter, and it would update the disk that that drive is on. It's easy enough to say /all because this is generally a harmless operation. If you have a machine that you ever run disk part clean on, so you repartition the disk from scratch, disk part clean automatically installs an NT60 Vista or above compatible boot sector. So that's why you don't have to worry about this as you're deploying newer operating systems. You only have to worry about it when you're going from XP to Vista or above. Easy enough. Something that's taken care of behind the scenes where you probably don't even realize it's there. DISM's another tool then that continues to have more functionality added over time, and as a result we could probably have an entire session on DISM, which would be exceedingly boring, but there are plenty of options there. There are options around servicing operating systems. There are options around imaging. So lots of functionality continues to get added into this with each OS release. So the things that you've done in the past using ImageX to get information about images, to mount images, all of that is now in DISM as well. Things that you used to do with VHDs through DiskPart, you can now do using DISM. So it can mount and unmount VHDs and WIM files. You can apply security updates offline or online using DISM. You can do a variety of different things. So let's look at a few of those examples. if we do dism/online/get, I think it's get features, it will show us for the currently running operating system what features are present and are they enabled or disabled. So in this case, I can see a lot of them here are actually disabled. If I scroll through that list, maybe there's one that I want to turn on. I can just find it in the list to figure out what the name of it is, and then I could say to add it. I don't want to add something that takes a long time, so let's see if we can find something that's kind of harmless. I've got quite a few of them actually installed already. Win Server Tools is pretty harmless. I can do dism online, add feature, okay, apparently it's not add feature. I think it's enable feature. Yeah, enable and disable. So add feature. And figuring out the syntax in these is always interesting, especially when I can't easily see my scroll bar here. Helps when I actually type what I meant. Enable feature. And then I need to specify feature name. So the example adds the game Hearts, which I don't think is present on a server operating system, so that won't help. I scroll back up here. I want to do Win Server Tools, save myself some typing. Feature name, name of the feature. And there's actually a /all switch where this /all switch says if there are any other dependencies that this one needs, go ahead and install those too. So I don't think there are in this case, but it doesn't hurt anything to specify /all. It'll take care of that. /all is actually new in Windows 8, so if you ever try this on Windows 7, you don't have /all, it means that you would have to install the dependencies yourself. Is it case sensitive on the feature names? I'm not sure. It isn't on the command line switches. They don't matter. But the feature names may be. I guess we can, easy enough, we can try that. So let me just try WINS. If it comes back and tells me that the feature is already present, or in this case it just finished immediately, it should be okay. Let me try disable. Oh, can't do disable all. So it doesn't seem to care at this point. Yeah, it's possible that that's something that they fixed. I've just gotten into the habit of making sure that I match case, just in case, because, yeah, there are behaviors like that that can be picky. So DISM can do all kinds of things. The types of things that you would want to do with it typically are probably around imaging, manipulating WIMs, manipulating VHDs, servicing operations, installing updates, turning off on and on features, and also configuring international settings. You can do that using DISM as well. But there are just so many options available in DISM. Just going through all the different help screens can take a while. So we won't spend a whole lot of time on DISM, but just remember the types of things that it can do. And if there are some things like that that you're looking to do, then go back to the help and see, well, what are the exact command line options for that? Keeping in mind that DISM/online is used to do manipulation of the currently running OS, where DISM image : and then the path to a mounted WIM is what you would do for offline servicing. Most of the offline and most of the online capabilities can also be done offline. Okay, so that's enough on DISM. The next item in the list is what? OSCD image. OSCD image is a tool used to create ISOs. And it's a simple tool in some cases, and it's a really complicated tool in others. So if you just want to create an ISO, it's easy. So we can do OSCD img and then specify the source path, like C:\source demo app. I think that was the right path. No, it was E. So I can take whatever folder and use that as the source for my ISO. That folder has subdirectories, it has files in it, it has all kinds of stuff in it. I can then specify that I want to create an ISO file. ctemp TechEd ISO. Now it's going to come back with a few errors based on what it finds in there because I didn't specify any other command line options. In this case, I need an option that says allow long file names, which first we see the first help screen. If we do -help ISO, it will tell us -n is a switch to allow long file names. If you just added -n, it will convert all the file names to uppercase, which I find kind of annoying. So you can also specify -d to allow lowercase file names. So in this case, all we need to do is add -n, -d. And now it fairly quickly creates an ISO containing all the files and folders in that directory structure. So we could then take that ISO and copy it to a server, mount it in a virtual machine, whatever we wanted to do with it, burn it to a CD. It's just a convenient way to move around kind of static stuff, especially when you're working with lots of virtual machines. That's the simple case, where we just needed to specify a couple of options. Where it gets much messier is if we wanted to create a bootable ISO containing an operating system, or even containing Windows PE. Because in that case, we need to do more stuff. And it's something that I can't possibly remember all of the options for. They're embedded inside of the Microsoft Deployment Toolkit and Config Manager when it creates ISOs. So it's just something that I put into a batch file. But you end up having to specify quite a few options to create a bootable install CD of Windows. So in this case, OSCD image. U2 says that I want a UDF version 2 ISO that's compatible with UDF version 101, that supports long file names. I don't even remember what some of these options do. O, H, W4. The YO points to a boot order file. There are some restrictions on where the boot files have to reside in the ISO. They need to be before a certain boundary point in order for the systems to boot right. So we have a boot order text file that ends up putting the boot files at the beginning of the ISO and everything that's data at the end of the ISO. We then need to specify boot sectors to put into the ISO, 2 of them, where the first one, which has an ID of 0, has to point to etfsboot.com. That's the old legacy BIOS boot sector. The second one, which has an identifier of EF, needs to point to the EFI sys.bin, which is an EFI boot sector. So effectively, we're always creating dual boot ISO files to boot on MBR, legacy BIOS systems, and UEFI systems. Okay, if that isn't bad enough, now we need to specify the path to the operating system source files and then an output ISO file. So want to recreate the original bootable Windows media, that's basically the command that you would need to do it. But figuring that out from scratch, that's not something you see in the documentation somewhere. It's something that you kind of have to figure out over time. But it's inside of the MDT logs, inside of the MDT scripts, and I just turned it into a batch file for convenience. So OSCD image is kind of useful to create ISOs. If you haven't noticed too, one of the changes in Windows 8 is that you can actually mount ISOs inside of Explorer. So if we go into the temp folder, I can find that TechEd ISO that I created, right click and say mount. There it is. It's now the F drive. No. Which drive is it? I saw a new drive show up. Yep, that's the right drive. So F drive now has all of the folders and files that I had captured into that ISO file. Of course, they're all read-only because it's mounted in a read-only ISO. I can do whatever manipulations I want here. When I'm done with it, all I need to do is right-click and say eject, and now it's gone. So much easier with Windows 8 and above to deal with ISO files because they can be mounted in Explorer. Same with VHDs. You can do the same thing there. Okay, that's OSCD image. Next tool is WDS MCAST, which is a command line utility used to do multicast file transfers. And you could do this manually to move files from a WDS server into Windows PE, but what it's typically used for is for MDT to multicast transfer an image to a new computer. So if you enable multicast in MDT, it runs this behind the scenes. The syntax for this one is a bit long as well because you need to specify a variety of information. We need to specify the name of the server, which is Contoso MGMT, the username to log into that server. I use the administrator account. The name of a namespace on that server, which in this case is source. What I want to do, I want to transfer a file. I want to display progress. I want verbose output. I can specify the source file, which is a relative path within that namespace, and a destination file, which is the local place that I want to drop it. Now on my WDS server, I went in and created a namespace. And in that namespace is nothing more than a logical name for a folder on the server. So I told it to create a namespace called source that points to /source, and then by using the relative path for the source file switch, I can multicast transfer any file under that directory structure. So if I run this command, it will prompt me for the password, which I could put on the command line if I wanted to. And then it will go and do the actual transfer. Even though this is verbose, the verboseness that you're going to see is not very verbose as long as things are working properly. The progress switch causes it to display a dot as it's transferring the file, so we can see that it's going through and doing that multicast transfer. Doing multicast transfer for a single machine is not terribly useful. It really doesn't get to be useful until you're doing maybe 10 to 20 machines at a time. There is some overhead involved in multicast, but when you get to larger numbers of machines, this can really reduce the amount of network traffic being generated when you're moving large files around. So not too bad to do. The main restriction with WDS MCAST and really multicasting with WDS in general is that it's only supported to go to Windows PE. It's not supported in the full operating system. I think it works, but it's not actually supported to run WDS MCAST in the full OS. There's some weird reasons behind that, but it's designed to be used from within Windows PE to transfer operating system images to the new system. That doesn't mean you can't use it for other stuff. You can copy app install files, you can copy whatever you want. I would just suggest only copying very large things and don't copy a whole bunch of different large things because each one of these effectively turns into a multicast session, and if you have 20 systems, each multicasting 20 different things, you're kind of defeating the purpose of multicast at that point with the collisions between those 20 different streams. But if you have one big thing that you're transferring, 20 machines transferring one big thing using multicast is very efficient. The multicast protocols in WDS are actually very creative. because they work kind of in a round-robin format. We've set up the namespace to do auto-casting, which means that the server's listening for new clients and allows them to join into the multicast stream at any point, even if the current block being transferred is right in the middle of the file. So existing machines have gotten to the middle of the file. The new machine starts at the beginning of that, well, at the middle of the file. When it gets to the end of the file, it just wraps back around to the beginning and fills in the missing pieces. So machines can join in, machines can finish up at any point. As soon as there are no more machines listening, the server stops sending and then starts waiting for the next client to come in, and then starts at the beginning of the file. The next machine joins in the middle. It continues to repeat that cycle. Very easy, because you don't need to make sure that all the machines start at the same time. You don't need to line them all up and then hit the go button. Instead, you can just kick it all off. Sure. Right. One machine doing multicasting of one file will end up being slower than just X-copying the same file. With the exact same command, right? It will. Right in the middle of the multicast stream. It might get the last 20 blocks of the file with this other computer receiving them at the same time. Then it circles back around to the beginning and fills in all that it's missing. Right. Yep. Yeah, we've done demos of this before where you just kind of walk down the row and kick off the machines, and then you can walk over to one of them and pull the network cable out of it, which with most multicast solutions would kind of hang the whole progress, but it'll just kick out that one machine and the others will keep going. There are also challenges where you have multiple different speeds of computers, where the slowest computer can slow down the stream. WDS in Server 2008 R2 and above allows for multiple streams with 3 different speeds, slow, medium, fast, and it will automatically push slower clients into the slower stream so that the fastest machines get the data as fast as possible. It's actually a fairly cool setup. It's actually in Server 2008 and above. So Server 2008, Server 2008 R2 adds the multiple streams and the ability to kick sessions up and down. Server 2012 doesn't add anything around multicast. It does add more around UEFI x86 systems and PXE booting, but not for multicast. 2008, 2008 R2, and 2012 do this. Just copying data down, right? Yes. Although that's a good point, because there is a change in Server 2012 and Windows PE 4.0. I believe they added a switch to this. No, they added a different utility. You do have the capability, and I don't remember the name of the executable off the top of my head, but I think it's WDS apply or something like that, where you can actually multicast and apply at the same time. So you don't have to copy the file and then apply it. It can copy it into RAM, decompress it in RAM, and write it to disk as one operation. So that is new in 2012. Okay, WDS MCast. That multicast session did complete. Let's switch back over to the server and look at, I think I missed one in the list here, but in any case, we'll look at USMT next. USMT allows you to capture and restore user state. So we would run this on a client operating system to capture all the data and settings for an account, and then deploy a new OS, and then run load state, which is another USMT utility, to restore them. So scan state, slash question mark gives us the command line options that we need. Oh, that doesn't work so well. Piping that into more basically creates something unreadable. Basically, we need to run scan state, and then where do we want to put the state? So let's just say C:\state. Then we can specify a variety of options like /O to overwrite any existing state store that might be there, /C to continue on non-fatal errors, /L to create a log file. It'll default to scan state, so we can leave that one off. We can specify /I and then the name of a migration file that contains the rules of what we want to migrate. So we could do mig.app.xml and mig.doc.xml. That should be good enough. Now I can never remember if it's singular or plural. mig.docs.xml. So then it'll go through and identify all the users that are on the system, all the apps that are on the system, all the different data file types, and it will grab all that data and store it in that particular folder. Now in this case, that would actually make copies of all that data. We can add some more command line options to make it not copy it, but instead use hard links. So we can say hard link, EFS hard link, no compress. Oh, EFS, not hardware, hard link. Which just makes the whole process faster because now it's not going to copy any data around. It's just going to create new links to all the existing files. Then when you deploy the new OS, the original links end up getting deleted, but it knows where those were. The new links are still present, so the files don't actually get deleted as long as that C:\state folder is protected and not deleted. You then install the new OS, you run load state, pointing it at the C:\state, telling it to restore the data. It can recreate any accounts that need to be created. It can recreate user profiles. It'll put the settings back into the profiles, settings back into the OS, all the files back into the original locations. It can translate the paths, so if you're coming from XP to, say, Windows 8, it knows that C documents and settings is now C:\users. It can figure out all of that on the fly and just do the right thing. So these tools are generally embedded in the migration process using MDT, using Config Manager. You can customize them by creating your own XML files that say, here are the rules of what I want to migrate. You don't really have to do a lot of customization though, because of the way MigDocs works. It does a pretty good job of identifying data. And the way it does that is through heuristics. The rules are fairly simple. The rule first says, well, if there are any extra folders at the root of the C drive that I don't recognize, migrate them. Second heuristic is if there are any file types registered on the system that point to apps that are able to open those file types, that probably means those file types are data. So automatically grab all the documents with those file types. So if you install a piece of software that knows how to open a PDF file, it will assume then that PDF files are data and need to be migrated. Same with Excel and PowerPoint and Word and all the other different file types. It automatically identifies those as data and migrates them. So fairly easy to do that. Load state. Pretty much the same way. We say load state. Actually, it's easy enough to just type over scan state with load state. Again, we specify where the current state is at. There's no /O switch in this case because we're not overwriting anything. Don't think there's any /C either. We do still need to specify the rule file, so mig.app.xml, mig.docs.xml, because it has to go through those translation routines that are defined in there. And I think the rest of that works as is. No, you don't specify EFS on this. And then it will restore all the user state that it just had backed up. Now in this case, that would actually duplicate the data because all the original files are still there, so I'll go ahead and cancel out of that because I don't want 2 of all my data files, but it's simple enough to run this as part of a deployment process. MDT Config Manager will both automate this for you so that you don't really need to worry about it. The third USMT utility then is USMT utils. USMT utils, which has a couple of options that are new in the Windows 8 version. There is a /extract switch, which allows you to extract the contents of a USMT state store. Maybe you want to get a file out of it, you can do that. There's a /verify that lets you check it for consistency. In case it appears to be corrupted, that will let you verify that. And then there's also a /rd switch that lets you remove a state store folder. That is important when you're using hard links because the hard links have 2 peculiarities with them. One is they're tied to the ACLs of the original files. So they can be a little interesting to delete if you don't have security to the original files. The second piece is that the original files may be in use. So when you tell Windows to delete the hard link, you could get an in-use error. Well, it's not really deleting the file, so this utility can actually just remove the hard link to avoid both of those issues because the original link may be there if the file still is supposed to exist. If there is no original link, then the file just goes away because there's nothing pointing to it anymore. So it's a useful tool for cleaning up hard link state stores. Maybe that's something you want to run after your deployment's completed. It's also useful for troubleshooting if you have any corruption issues or need to extract a potentially missing file out of a state capture state store. So scan state captures, load state restores, USMT util can do some cleanup and can do some fixing. Next item in the list, Windows PE. If you really want to, you can build your own Windows PE image from scratch. That can be done from a machine running the assessment and deployment kit by opening up an elevated deployment and imaging tool command prompt. So when you install it, you'll see that it creates a shortcut here, deployment and imaging tools, right click, say run as administrator. From there, I can do copy PE, which is a batch file where I tell it, do I want an AMD 64-bit boot image, an x86 boot image, or if I were an OEM, I could actually create an ARM image. In this case, we just had the first 2 options. So you specify the platform that you want to create and then the folder that you want to create it in. So I could do copy PE, AMD 64, C temp, TechEd PE. And it'll take care of copying all the files necessary for that boot image into the folder that you specified. So it gives you a starting point for now customizing that boot image. There's then another batch file after you're done customizing it called Make Win PE Media. Where you can say what kind of media you want to create, either UFD or ISO, pointing it to that folder, and it will take care of running OSCD image to make the ISO file out of the folder that you've created. So it's basically provides the first step, which is to copy all the files into a folder structure. It provides the last step, which is turn it into an ISO. It doesn't provide the steps in between, which would be DISM commands to add additional features, DISM commands to configure, DISM commands to do whatever you wanted to Windows PE. You can inject drivers using DISM. You can do all of this stuff. So does the first step, does the last step, you do all the manual stuff in the middle. Config Manager, MDT, do all of this stuff for you, which is why most people never had to run these batch commands anymore. You don't generally create a generic Windows PE image yourself using this mechanism. It's not hard to do, but there are a few steps required to do that. If you just wanted a simple one, you could actually execute those 2 commands back to back and you would get an ISO out of it. But it would just boot into Windows PE and give you a command prompt. Okay, next one in the list is the Windows Performance Toolkit, which is a useful tool that has been covered in a couple of sessions. We'll look at it real quickly here from another machine, if I can get to that machine. It's useful for monitoring whatever Windows is doing and capturing trace information that you can then drill into to figure out why is Windows taking so long to do something. So I've installed it on this computer, and we can actually see the shortcuts over here for it, the Windows Performance Recorder and the Windows Performance Analyzer. So the recorder would let you create the trace information, and then the analyzer displays it for you. But the scenario that's a little more interesting is to monitor a boot up. So we can, actually I should have used that command prompt. We can run an elevated command prompt, and what we would typically do is we would install the redistributable version of this from the ADK on this system, which is something I did in advance, the simple MSI. Once it's there, it gets installed to Program Files, Program Files x86, Windows Kits 8.0, Windows Performance Toolkit. There we have a few executables, wpa.exe, Windows Performance Analyzer, wpr.exe, Windows Performance Recorder, and xbootmgr is the other interesting one. So if we do xbootmgr, it displays, it wants a few things specified to it, so we can say trace boot. So minus trace boot. Trace boot. And it'll start up a trace. It will reboot the computer, and then it'll capture the trace information as the computer starts up. So then after the startup is complete, we can log back in. It'll display a countdown for like 120 seconds where it continues to capture trace because there's additional background stuff still going on after a reboot. When it's done, we can either wait 120 seconds for that to finish, or we can click finish on the dialog when it shows up. It then creates a ETR trace file in the same folder. We can then load that with the Performance Analyzer and then start drilling into the data to see what happened during that boot up process. So this tool gets used by a bunch of Premier field engineers and Microsoft support people to try to figure out why startups are being so slow. The hardest part about it is analyzing the data. So when we log in, we should see the countdown. Eventually. And then we can stop the trace and open up the file. So go over to the desktop. Should see a dialog show up here shortly. There it is. Delaying for 120 seconds. We'll go ahead and say finish. Yes, please go ahead and elevate. Stopping the trace. And now we have an ETW file, which it says is ETL file, which it's saved in that same folder. So we can then run Windows Performance Analyzer. And find the file boot underscore base plus C switch underscore 1.etl. That just gives us a graphical view of the trace information that shows all the processes, everything that was going on during the boot process. And the hard part then begins of drilling into that data and trying to figure out exactly what it means. Where are the actual delays? What was going on to slow the boot process? So there's the file. Open it up. Then based on what we want to see, we can add different items of detail into Graph Explorer and then start drilling in. So we can basically see a timeline of the whole boot process and what processes started when, how long they took, when they started, when they ended. There's additional information about CPU usage, IOs generated, the amount of memory consumed. So it's a lot of detail about the startup process. Deciphering it, yeah, there were a couple of other sessions. In fact, there's one going on at the exact same time as this one, where they show these tools and how they've used them to try to figure out what's going on during the boot up process. So check out those systems to get into more detail. Question?
Does it really just display the info and it's really up to you to make an assessment?
Pretty much, yeah. It does a great job of letting you drill in and try to identify the data, but it doesn't really provide any analytics to help figure out what problem is there. So if it's something you look at it and say, yeah, this is a bit much for me, at least you can pick up the phone, call support, and say, I'm having startup issues. I've run a boot trace. I can provide that to you. Can you tell me what's going on? And they can analyze these because they do it all the time. So that's the performance toolkit. Assessment toolkit, we're going to have to skip over that one because we're a little over time, but basically it runs a set of tests where these tests can do things like measure your video performance, measure your graphic performance, measure your driver load times, lots of different tests that can be executed, storing the results in an XML file, which you can then analyze. You can then compare it against other systems. So there's lots of tests there. You can also build your own tests and use this as a framework to execute those. So that's kind of the standalone version of that. And like we talked about before, there's also Windows Assessment Services, which is more of the all-encompassing, take over your lab type of system to do the same thing. All right, that is pretty much it. That is all 17 of the tools that are included in the ADK. Maybe you will be running some of these as part of your job, but most of them just take into account that you're running these behind the scenes as part of MDT, as part of Config Manager. All right, thanks a lot. If there are any other questions, find me up front, find me outside after the session, but thanks for coming.